Hi folks, Mr. Long here. I'm going to do a screencast today to get you ready to solve exponential equations. And what's required here is to make sure you understand your exponential definitions really well, and then being able to work with what are called common bases. So just a quick review so remember, if we have 2 cubed equals 8 right here, that the 2 is a base or the repeated factor, the 3 is the exponent. That all taken together, the 2 and the 3, or 2 to the exponent 3, 2 to the 3, or the third power of 2 is called a power. Okay, that's a power. When you get the answer to that power, that's called an evaluated power. Remember that you do not say 2 to the power of 3. No such thing exists. It's the third power of 2, or it's 2 to the 3, 2 to the exponent 3, and this whole thing is a power. Okay, the answer is an evaluated power. That's really important. Okay, so why are we going to do this? Why are we going to study this idea of what's called common bases? Well, you're eventually going to be solving equations like this. And you might notice something. Think about 25 and 5. Is there a common base that they can be represented with? In other words, is there a way that you can represent 25 and 5 with the same base? So is there a way, what's another way of representing the number 25? With an exponent. Well, you could represent it as, I don't know, 5 squared. And that 5, how can it be represented with an exponent? 5 to the 1. Okay, so 25 can be 5 to the exponent of 2. This can be 5 to the exponent of 1. So we could get a common base. So what we're going to go through now is a series of activities that allow you to develop an understanding of common bases. So here we go. So just going through this first, we want to get patterns and powers as common bases. So look at this first question. So we're just getting used to using the chart. So represent 64 as a power with a base of 8. Okay, so with a base of 8. So you can see right here I've got 8, I've got 64, and now I need to pick the correct exponent. The idea is to find 64 in your table. Well, there's 64. But it would be 4 to the exponent of 3. That's not what I want. I want a base of 8. So I go down to the row with 8. Oh, and there's 64. So I go to here and I pick 2. So it's 8 squared. Represent 64 with a base of 4. So I go to my 4 right there in the chart, and I go across till I get 64, and it's cubed. Okay, next. I want to represent 64 with a base of 2. So the bases are down here. So 2, and I go all the way across till I get 64, and I get 6. Okay, now I'm going to do it for 16. So 16 with a base of 4. 16 with a base of 4. Well, base of 4, 16, oh, that's easy. That's 2 squared. And then now I want to represent 16 again, but with a base of 2. So how many times, this means how many times do I multiply 2 repeatedly, or repeated factors of 2 to get 16? So I have to go to a base of 2, and I go all the way across to 16. It means I have to multiply it repeatedly 4 times. Okay, finally, represent 8 as a power with a base of 2. Remember, a power is a base with an exponent on it. Represent 8 as a power with a base of 2. So that's pretty easy. Base 2, here, go across till I get 8, it's cubed. So now I'm going to introduce you to the idea of common bases, or representing numbers. It's like having a common denominator with a fraction, right? It's a very similar idea. So if we look here, actually it's very closely linked. So I have here a base of 8, 4, and 2 for 64. I have a base of 4 and 2 for 16. I have a base of 2 for 8. So what base is common to all three groups? Well, I've got a 2 with 8. I've got a, wait a second, let's look here. 8. Is 8 common to is 8 in 64? Yes. Does 8 go with 16? No, because if I go across 8, I won't see that I get something with 16. And what about that? No. 4 goes with 64. 4 goes with 16. It doesn't go with 8. What base goes with all three numbers? Well, 2 goes with 64, 2 goes with 16, and 2 goes with 8. So the common base for 64, 16, and 8 is 2. Okay, now here's the most important question. When numbers have a common base, how are they organized in the power chart? Well, I want you to look at something. Let's go across the base 2 row. 2, the base of 2 can be made into 4, 8, 16, 32, 64, and 128. 4, 16, 64. So it looks to me like a common base. If numbers have a common base, they'll be found in the same row of the power chart. Remember, this thing here is called a power chart. So a common base means that the evaluated powers, will be in the same row. Because remember, these numbers here, 64, 16, and 8, are the evaluated powers. Okay, the evaluated powers. So again, it looks to me like these numbers will be in the same row. Okay, the same row. And you're going to fill that in when you go ahead and do your work. Okay, so what I'm going to go through now with you is you're going to be able to do the rest of those, and I'll just pick a group here to work with. Okay, and I'm just going to do some of the extra ones, the additional ones rather, and we'll go from there. Okay, so let's do this. We want to get a common base for 125, 25, 625, and 1. Okay, a common base. So what I need to do is I need to look for these numbers and find all of those numbers in the same row. By the way, you'll never find a 1 in a row, and we'll talk about that in a second. So let's see here. Yeah, I'm going to have to do a type over for this one. Okay, so 125. 125 and 25. See if I can find those in the same row. There's 125, there's 25, there's 625. Okay, so it looks like I found the row. So it looks like it can all be represented with the base of 5. So 625 is 5 cubed, 25 is 5 squared, and 625 is, where's 625? Right there. 5 to the exponent of 4. Or sorry, that should be 5 to the exponent of 2. And this should be 5 to the exponent of 4. Now, here's something that you may not know, but anything like 100 to the exponent of 0, so I'll just make a point of looking at this. So let's make these bigger. So 100 to the exponent of 0, what does that equal? Well, if you do it with your calculator, you're going to get 1. So that equals 1. Okay, that equals 1. So why does 100 to the exponent of 0, why does that equal 1? Okay, why is that? Well, remember that positive exponents mean repeated multiplication. Negative exponents means repeated division. So an exponent of 0 isn't multiplication and it isn't division. So what is it? Well, you're multiplying by, it means don't multiply by 100, right? So an exponent of 0 means don't multiply or divide by 100. Just leave the number. Well, our initial number when we're multiplying and dividing is always 1, right? It's always 1. So when we're adding and subtracting, our original number is always 0, right? But when we multiply and divide, our original number is 1. So an exponent of 0 means don't multiply, but don't divide either. And so our value is 1. So if I want to get a power, evaluated power of 1, I just need to make it 5 to the exponent of 0, right? 5 to the exponent of 0. And that's how we get 1. So those are in a common base. Last one we'll do is we'll look at some negative exponents, okay? Some negative exponents. So first thing here, 1,000, okay? 1,000. So 1 over 1,000. So I look up 1,000 in my chart. There's 1,000 in my chart. So if I have 1,000, I have to find 1,000 somewhere. There it is. It's a base of 10. So 1,000 base 10. So it's 10 to the 4th is 1,000. But since I'm dividing by 1,000, right, I've got repeated division instead of repeated multiplication. So we remember from negative exponents that it's going to be 10 to the negative 3 now, right, because it's a fraction. 1 over 10. Now 1 over 10. Oh, 10's right here. So how many times do we have to multiply 10 by itself to get 10? Well, once. So I know this number here is going to be 10. I know that. But it also, I have to think of it as also having an exponent of negative 1. Because 1 over 10 means divide by 10 once, right? Just as we talked about. 216. I've got to find 216 in my chart. Where is 216? 216 is, this is hard. 216 is 6. Okay, 6 to the exponent of 3. But I'm dividing by 216, so that must be done repeatedly dividing by 6. There we go, negative 3. Okay, folks, so 6 to the negative 3. Make sense, everybody? I hope it does. All right, so I will go from there, and I'm going to go down to not the next one, but this one here. So I'll do group A here, and let's see. Oh, I need to copy down one of these, don't I? Oh boy. Okay, so here we go. So 1 over 64. So I've got to find 64 on my chart. Well, it's 4, but I'm supposed to get a common base. Oh, if I'm going to get a common base, I better look at all the numbers at the same time. So 64, 128. 64, 128, and 1. So I better look for 64 and 128 in the same row. So I saw that 4 row. It's got 64. Does it have 128? No, it doesn't. What about the 2 row? 64 and 128, 6 and 7. Oh, okay. So 1 divided by 64, 1/64 is, 64 is 6. Okay, so that's a 6. Is it a 6 or is it a negative 6 though? Okay, well, sorry, it's going to be the base of 2, and then it's going to be negative 6, right? It's going to be negative 6, that because it's repeated division. And then 128 we saw was 7. So our common base is 2, and we want to get 7 there. Now what about 1? I need a common base. Well, I can represent any power as long as the exponent is 0 to be evaluated to 1. So I could pick 2, and all I have to do is put an exponent of 0. Okay, exponent of 0. Now I have common bases. So remember, anytime you want to represent, you can represent 1 with any base as long as the exponent is 0. Okay, so what you're going to do when you're, now that you've watched this, is you're going to complete this spreadsheet, this Google Sheet. You're going to work through every single question, and then you're going to practice some solving of linear equations just to do some review, because you're going to need to do that as well later on. All right, folks, so good luck in getting your work done. Remember, though, you can pause and rewind this at any time at all. All right, good luck on your work.